Hey, this is Mr. James. In this video, we'll be talking about functions, domain, and range. The majority of this video will be taken up not by exact definitions, but by a lot of examples to show you what I mean by the different vocabulary terms you'll see in this video. Let's get started with ordered pair. An ordered pair is two numbers which form an xy point or a coordinate. Typically, we think of the first number as our input and the second number as our output, with a comma separating them and parentheses on the outsides. A numeric example might be 2, 7, or an example from biology about the food chain might be birds, fish, and we'll use this example a little more in a second. A relation is then a collection of ordered pairs. For example, a numeric example could be 2, 7, 2.1, 5, and 1/2, 5. There's some sort of relationship between those pairs of numbers. Another example could be to look at the food chain in terms of who eats who, what the consumers are. So for example, birds eat fish. Humans also eat fish. And humans also eat birds. So in this way, we have a collection of ordered pairs with a relationship between the two inputs and outputs. A function is a specific kind of relation in which every x value is paired with exactly one y value. A numeric example might include 2, 3, 3, 4, 5, 1, and 6, 1. Notice how none of the inputs, the first numbers, are doubled or sent to different outputs. 2 goes to 3, 3 goes to 4, 5 goes to 1, and 6 goes to 1. It's okay that both 5 goes to 1 and 6 goes to 1 as long as each input has only one output. Now, we can't use the food chain example for a function. That's because in our example before, we had humans eating fish, but also humans ate birds, which means for that one input of humans, there were multiple outputs, fish and birds. On the other hand, the subjects taught is a function. Mr. J teaches one subject, math. Mr. B teaches one subject, English. Ms. K teaches one subject, math. Again, it's okay that math is repeated as an output as long as each input only has one specific output. Getting more specific, an invertible function, also called a one-to-one function, is a specific kind of function in which every y value is paired with exactly one x value. For example, in this numeric function, we have 2 going to 3, 3 going to 4, 5 going to 1, and 6 going to 2. It's definitely a function because none of the inputs, 2, 3, 5, and 6, go to two different outputs. But it's invertible because the outputs, 2, 1, 4, and 3, come from only one input. The previous example, up here, is not an invertible function because if we look at the output 1 could come from 5 or 1 could come from 6. So that would not be invertible. Similarly, the subjects taught example is not invertible either. Two teachers teach math, and so I couldn't go from the output, math, back to only one input. It could be Mr. J or it could be Miss K. A real-life example of an invertible function is maybe your student ID number. Nick has one specific number, 1245. Colby has one specific number, 1275. And Lester has one specific number, 1268. But in addition, each of the numbers going backwards correspond to only one specific person. That's why they're called invertible, because we can invert the input and the output and still have a function. 1268 only goes with Lester, 1275 only goes with Colby, and 1245 only corresponds to Nick. Next up, we have the terms domain and range, and these are two terms that we'll be using very often throughout our discussion of functions. The domain is the set of all inputs of a function, whereas range is the set of all the outputs of a function. Let's start by using this example up here and find the domain and range. Remember, the domain is the set of all the inputs of a function, so the domain would be 2, 3, 5, and 6. The range is the set of all the outputs of a function, 3, 4, 1, and 1 is repeated. Some quick notes about notation. When we're writing domain and range, we're going to write them inside curly brackets like this, and separate the elements of the domain and the range with commas, like that. In addition, if an element of the domain or the range is repeated, like this 1, it's not necessary to write the 1 more than once. So in the range, I only wrote it once. In addition, the order you put things in the domain and the range doesn't really matter. For example, the range could be written 3, 4, 1 or 1, 3, 4. Typically, we'll put them in numerical order, like this right here, 1, 3, 4, but putting them out of order doesn't make it wrong. At this point, I'd like you to pause the video and try using the student ID number example to write the domain and range for. Go ahead and pause the video now, just so the answers for domain and range come up on the screen in 3, 2, 1. And here we have the domain and the range of the student ID numbers. Let's move on to talking about different ways we can represent functions. There are a few different ways we can represent functions or relations in general. They include tables, mapping diagrams, graphs, and algebraically. Let's start by talking about tables. A table is a method to represent a relation by organizing the pairs into two columns. Typically, the first column will be our input, often called x, and the second column will be our output, often called y. For this example, I'm going to use the food chain consumers relation that we talked about at the very beginning of this video. So, in this example, birds went to fish, humans ate fish, and humans ate birds. So, looking at my table, it should look something like this. We have birds eating fish, humans going with fish, and humans going to birds in our two columns of our table, the inputs and the outputs. Note that it doesn't have to be a function to be put into a table. We can actually tell it's not a function because we've got the same input, humans, going to two different outputs, fish and birds, so it's not a function at all. What I'd like you to do now is pause the video and try making two additional tables out of the numeric examples we used in function, right here, and another table out of the numeric example we used in invertible function, right here. Go ahead, I'll leave these up on the screen, pause the video, and draw those tables. The answers will be up in 3, 2, 1, and here we are. Notice that we can tell the second table is a function because none of the inputs are repeated with different outputs. However, it's not invertible because the outputs, 1 and 1, are repeated for different inputs. Where on the other hand, the last example here is an invertible function. Let's label our tables with relation, function, and invertible function, so we don't forget those things. One last bit of vocabulary. All of the elements in the input, remember, are called the domain, and all of the elements of the output are called the range. Important to remember, especially as we go into mapping diagrams. Mapping diagrams are methods used to represent a relation by listing the x values in one area and the y values in a separate area, then drawing an arrow between the pairs. I'll use the same three examples from above to illustrate what a mapping diagram looks like. First, start by drawing two bubbles like this. One will represent our input, or our domain, and the second will represent our output, or all the elements in our range. Next, go ahead and list all the elements of the domain and all the elements of the range. And just as if we were listing them separately, we're not going to list any repeat values. So although humans are listed twice in the domain and fish are listed twice in the range, we're only going to put them once in each. Lastly, we'll draw arrows between the domain and the range to demonstrate the relationship between them. So we know birds go with fish, birds eat fish, so it's going to have an arrow. Humans eat fish, so we'll have an arrow this way as well. And humans go with birds, humans eat birds, so that's going to look like that. And our mapping diagram is done. We can tell right away that this is not a function because one input in our domain, humans, goes into fish and birds, two elements of the range. That's not a function. What I'd like you to do is pause the video here and attempt to create two more mapping diagrams, one to illustrate this relationship right here, this function, and one to illustrate this invertible function. Pause the video now. The answers will be up in 3, 2, 1. And here are 2 examples. We can tell this middle example here is a function because every element of the domain, every input, has only one arrow leaving it, signifying that it's going to only one element in the range, the outputs. But it's not invertible because if we look at the range, we have 2 arrows leading to this number 1 right here, which means there are 2 possible inputs that lead to that only one output. On the other hand, this last example is clearly invertible because the arrows leaving the domain only leave from one element, one input each, and heading to the range, they're all going to one element each, and there are no elements of the range, no outputs, that have more than one arrow heading towards them. So again, we've got an invertible function, and a relation that is not a function. Next, let's talk about graphical representations. Graphs are methods to represent a relation by plotting the ordered pairs on a coordinate plane. We're going to do a couple examples here, so let's quickly sketch out 4 just blank coordinate planes, 4 blank graphs. Typically, we call our horizontal or x-axis the axis of the inputs, and our y-axis or this vertical axis will be for the outputs. At this point, I'd like you to pause the video and create your first 2 graphs by plotting these 4 points. The first one has 2, 3, 3, 4, 5, 1, and 2, 7, and the second graph should contain 2, 3, 3, 4, 5, 1, and 6, 1. Pause the video now so you can leave these up on your screen. The answers will be up in 3, 2, 1. Now we can tell that this first graph is not a function, it's just a relation, and the second graph is a function 2 ways. First, if you look at the ordered pairs, you'll notice that the input of 2 maps to 2 different outputs, 3 and 7. You can see that on the graph by looking at the input of 2, going up the graph and noticing that the output could be 3, or if you continue, the output could be 7. On the other hand, the second graph is a function, none of the inputs go to multiple outputs, and you can tell that as you look at your inputs, they only hit 1 point on the graph. We can also use something called the vertical line test to see this. The vertical line test states that if you take a vertical line and drag it across your graph represents a function if the vertical line only hits 1 point at a time. As you can see, as I'm dragging it across, it's only hitting 1 point there, 1 point there at a time. So that's a function. On the other hand, this first graph, it's hitting 1 point there, 1 point there, but 2 points here, which means at that spot, this is not a function, and so it is only a relation. Again, because this one input at 2, it's hitting at 2 different spots, signifying that it has 2 different outputs, not a function. So our first 2 examples used points in a more discrete graph, but the vertical line test could also be applied to a more continuous graph. For example, if I had a graph such as this, and perhaps a graph such as this right here, which one is a function? Well, using the vertical line test, we can see that the first graph passes at all points. As I drag my vertical line across, the vertical line is only hitting the graph in 1 point at a time. Whereas the second example, okay, right now it's only hitting the graph at 1 point, but right when we get to here, where the input is 6, it seems we have 2 outputs. For 6, we have an output of, looks like 3.5, and also 7. So at this point, the graph fails the vertical line test, and it is no longer a function, only a relation. So to recap, we have 2 relations and 2 functions. Lastly, let's talk about the algebraic representation. An algebraic representation is a method to represent a function through an algebraic equation, formula, or rule. Here we have an example where x is the input and f of x represents the output of 3 times whatever x was plus 1. And here's a table with a couple examples. For example, if x was 2, then f of 2 would be 3 times 2 plus 1, or 7. This ends our video on functions, domain, and range.